this one. Yeah. Yeah, just allowing a little bit of time for things to boot up. Okay. Close this. So let's go. All right, let's see. So this is this one here. I'll probably just do that. What do I have? Do I have anything available? Exam 2. So at the bottom, practice not graded. Okay. So I'll make one for exam 3. Manage. Create homework. Study guide. Exam 3 should be what? Chapter 2. So let's go to chapter 2. Come on. Let's do it one section at a time. How many questions? Yeah, it's a good amount. Let's go like this. Remove these. Hopefully those are not in my exam. Those run amok. I do kind of need to check. Oh no. Come on. I'm gonna glance at something real quick before we get started. I gotta make sure these are not in my exam. Add. And then this one. Okay, that looks good. Okay. All right. I think it needs to say practice not graded somewhere. Next. Save and assign. But I wanted to say practice not graded. So let's edit. Here. Practice not graded. Save and assign. And let me check one other thing and we'll get started. So I want to go down to week 13. I just want to glance at this exam and make sure some questions. Let's see, question details. I just want to make sure I do not see the infamous. Okay, that looks good. And if it's missing from there, it's probably more than likely not the other ones. Okay, those look good as well. Okay. I think we are good. Okay. Let me open this up. Practice not grade exam 3. Be consistent, edit. Oh, well, let me cancel. That doesn't matter. I'm coming, guys. Cancel. Let's go, let's go. It's just things boot up kind of slow. Let's see. Here it is. View. Okay. Practice not graded. 77. Okay. Let me do a new screen. Give me a random number between 77. Generate. Cool. We'll start on question 25. Done. Let me share my screen. Come on, let's go, let's go. Start the broadcast. Okay. All right. So we'll start off here. Let's see. All right, gentlemen. So welcome. No real announcements. Let me pull up a calendar real quick. So like here should work. Okay. So we are in the home stretch. You know, I think we have what 2 more sections of new material. So this week we're focused on exam 3, right? The spiel here: unlimited attempts. The system is set to take your highest score. I think it's due. It should be due at the start of class next week on the 18th. So as we approach the end of the semester, keep in mind that you have access to all of your old assignments, including exams, right? So if you're trying to maximize your grade, you want to definitely maximize your exam scores, right? So, do your best with this one. You get unlimited attempts. And then once you get this one to where you wanted to be, I would encourage anybody, honestly, if you're below like a 90%, I would encourage you to go back and like maximize the scores on your old exams. You have nothing to lose and everything to gain. If you get a score lower, nothing is taken away. If you get a score higher, then your overall grade is higher. And that's across the board, like no matter where you are. Anything can happen. Like I've had students that, procrastinate until like those last 2 weeks of class, and then they get everything submitted and they got a decent score. Generally, I mean, I don't want anybody that's kind of near the top to get lax, so I'm not going to offer that one. But if you catch my drift, But honestly, whatever grade that anybody wants, it's really just there waiting for you to take it, right? Okay. So let me see. So this week is exam 3. Let me see. So I think on that week we meet once. Next week, yeah, we can be done. Why was it off before? Let me see. So this week is exam 3. Next week is what? I think it's section like 3.1. Oh, okay, I remember now. Next week on Monday, right? Monday we'll do 3.1. And then on Wednesday, normally we do a homework session. We're going to go ahead and do the final section. I think it's section 6.4 on next Wednesday. So then what that'll do is that'll give us 3 sessions left in review for the final. Right now, it's a safe assumption that I'll be preparing your final, so you can anticipate the format or the structure to be similar to exams 1, 2, and 3. So then that week of November 25th, that's the week of Thanksgiving. We're going to meet on that Monday. That Monday, we're going to review exam 1, right? So we're just going to focus on exam 1 on that Monday. We're not going to meet on that Wednesday. I think the school closes at noon, but I think it's okay if we just don't meet. Like it'll be okay. Because the school closes at noon, I'm not meeting with any of my other students. Now I could be available if anybody needs me on that Wednesday, the 27th. But for right now, I'm going to release you. So we'll take the Thanksgiving break from the 27th, through the end of that week. And then the last day, so that Monday, December 2nd, that's we're going to focus on exam 2. We're going to review exam 2 that day. And then that Wednesday, December 4th, that's the last day of class, all right? So on that day, we'll review exam 3 along with those 2 additional sections. So we'll try to make sure to get those 2 sections in there. And then the reading period is December 5th and the 6th. And then finals is that second full week of December. So that's December 9th through the 13th. That Friday the 13th, that serves as the hard deadline for all assignments, not only your final exam, but all assignments, right? So, don't expect anything. Don't expect that you can submit anything past the 13th because we have to calculate final grades and submit them promptly. Yeah, and so you can anticipate that the final to become available that Sunday, December 8th, more than likely at 11 a.m. And for 5 days, you can earn max credit. I mean, it's due. You got 5 days before the hard deadline, right? So again, this week we're focused on exam 3. Again, if you can ask questions from your exam during class, and we can actually work on it together. So if you're working on it, or if you're stuck on something, or if you have a question, this is a great time, and we can actually work on it together. Your very question. So just basically, you just have to ask. Closed mouth, don't get fed kind of deal. I think that's the meat and potatoes. Again, if anything isn't clear, feel free to unmute yourself or type in the chat to get my attention if we can talk about it. Otherwise, we're gonna just kind of shark repeat it, and I still have not. Okay, I can use it here. Let's go ahead and get the party started. Oh my goodness. Sorry. I went out of town for my sister's wedding about a week ago, and I still have not packed everything. I'm proud of myself though. I'm doing better. I I at least washed my clothes and somewhat I guess I folded up the essential items. You know how that goes. This realm is crazy. Look, is I really want to share videos with you guys. Like, matter of fact, I think I am going to pull it up. I just got to find it. Hang on, because it's a ridiculous video, but he makes good points. But it's really not appropriate. Like he kind of talks about. He was like, "Oh, I just graduated." Oh, he was like, "I'm ready for my first job." He was like, "Oh, you need experience for that." He was like, "But I thought I went to school for that." He was like, "No, no. First you got to get experience, then you go to school, then you got to get experience, then you get your first job." He was like, "But I got a degree in accounting." He was like, "Well, your rent is $3,000, so you're gonna need a job." He was like, what job could I do?" He was like, "Well, maybe you can go work at McDonald's." He was like, "What? I got to do. I went to school for 4 years. What the hell? What's going on?" He was like, "Well, good luck counting them fries." He made it really funny, but that's real talk, right? So I bring that up, or I reference that story because I encourage you. You guys. While you're a student, in this realm, you deliberately and intently have to make a plan to find work afterwards. If you don't like make a plan to find work before you graduate, it's ridiculous. Because I literally ran into the same thing. Like, I have my degree. I have at least 2 degrees, a master's in applied mathematics, and I still couldn't find work. Now, I mean, honestly, if I kept pushing and I worked around, I'm pretty sure I could find something. But I was like, no, this is a joke. So I released it. I was like, I'm just going to use it to strengthen myself. And I just decided to go into business for myself because I was like, I was not interested in playing those games. Um, so, but at least while you're a student. Oh, and then he was like, well, maybe I can go back to school. He was like, it's too late. You've already graduated. It was ridiculous because, like, that's exactly what I kind of went through. But I mean, it's not that cut and dry. I feel like as a student, things that are important are internships. And idealistically, you want to already be working at the job that hopefully you can be working when you graduate. That seems to be the name of the game. Like, you need to find something before you graduate. Because after you graduate and then you have your degree after a certain amount of time, a year or two, it's like they prioritize new graduates, right? And it's like he was like, I go to apply for one job and I'm overqualified, and I go to apply for another job and I don't have enough experience. I'm like, what the fuck? Like, and that's exactly what was happening. And like, honestly, I mean, to be honest, you know, a lot of the stuff you don't even really need a degree. You just need to get your foot in the door and you just need to be working. That's it. And a lot of it you learn as you go, you know. And so that's being honest. Um, but again, I know plenty of people that got their degrees and used it and they're doing well. Like, I really think it's based on the individual and what you want, you know. But I would highly, highly, highly encourage each of you to try to get like internships before you graduate and try to already be working at whatever job on in some capacity. Have your foot in the door, something in whatever company or doing whatever it is you want to do before you graduate. Because after you graduate, it's like a ticking time bomb. So anyway, that's the synopsis of that little clip. And I've seen stories like that before. But maybe maybe at the end I'll pull something up and share it with you guys. It's like a minute or two. Let me see. Okay, so anywho, let's go ahead and do what we need to do. Let's talk over here. We said question 25. Where is my phone? That's and like I'm doing one of my peeves. I hate like clutter. I'm coming down. Where is it? Like, I hate clutter, but like I said, I'm still unpacking and fixing stuff, and so everything is my way of dealing with the clutter. I kind of put it in a pile and I just work on it piece by piece, like for real. Anywho, but yeah. Okay, so question 25. All right, let's see what this is looking like. Let's go here. Oh, this is a fun one. So this question comes from section 2.1. Oh, did they change the format? Seems like they went back to where it was. Okay, that helps. This question comes from section 2.1, question 57. I think we're going to need some notes here. Fencing with a length of 540 meters surrounds two identical playing fields with a common side. The fields can be side by side and separated by a fence as shown in the figure. Find the dimensions and the maximum area of each field. Okay, so let's get a copy of this. Let me zoom out just a little bit. I feel like that's a little bit better. Seems like they're changing a lot of stuff. So yeah. So, you know, when it comes to this whole academic career, just do the best you can, but, you know, do your best, but don't take it too serious. Like, because there's always another way. You know, like if you're talking to somebody and they're not saying what you want to hear, whether it's me, whether it's another professor, whether it's anybody, if you're talking to somebody and they're not saying what you want to hear, you're just talking to the wrong person. And then where there's a will, there's a way. You know, there's always another way to get things done. So, you know, it's just whatever you focus your mind and your intent upon, and you just stay focused on it until it happens, and it will happen. Okay. All right, let's see. So I want a copy of that. I guess I'll do this. So we'll go, I'll just get a copy. Duplicate. Did I duplicate it? Nope. Oh, maybe that was copy. Oh, there's duplicate. Okay. All right. And then I want to crop because I just want this image. That's good. Okay. So we're going to use this. All right, let's see what we have. Okay, it says fencing. So we'll say the perimeter, right? It says the length is 540 meters. So we'll say that the perimeter is 540 meters, okay? Surrounds two identical playing fields with a common size. The fields can be side by side. Find the dimensions and the maximum area, okay. All right, so we'll let this length be our X from here to here. All right, we're gonna let that be X. And we'll let this be Y from here to here. Okay. So then we should, let me see, find the dimensions and the maximum of each field. Okay. Instead of that being my Y, and because we want it for each field, what I'm going to do, I'm going to let my Y, I'm going to try from here to here instead. Okay, we're going to do that. That's just what I resonate with. Okay. So then perimeter, right? So that's the fencing. All right. So what is the perimeter? The perimeter is what? The distance around the outside. So we add up all the fences, right? So we got what? 1, 2, 3 X's, right? So we're gonna say 3X plus how many Y's? The way we have it drawn, right? 1, 2, 3, 4. So plus 4Y. And that total distance should be 540 meters, okay? Now we're asked to maximize the area. Let me see. Find the dimensions and the maximum area of each field. So the area and the area of each field is going to be what? X times Y. So rectangle. So if we're taking the area of one field, we're going to say X times Y. Okay. So let's solve for Y in the first equation. Okay. So if I solve for Y, I'm going to subtract my 3X. So then we'll have 4Y equals 540 minus 3X. Okay. And then divide both sides by 4. Y equals, let me say 114 would be what? 325. Okay. Minus 3/4 X. Divided each of those by 4. There's a 1. 1 is a 12, 3, 12, 20. So that's 5. Yeah, that looks good. Okay, so now we have Y in terms of X. Let's take this equation and plug it into our second piece of information, that max area equation. Right? So now again, our goal is to maximize the area And that's going to be x times y. So that's going to be x times our y is 135 minus 3/4 x, okay? So then let's expand and simplify this guy. So we can distribute this x, okay? So then from there we'll get, and I'm going to put it in descending power order, negative 3/4 x squared plus 135x, okay? So now we want to maximize this area, right? We know the shape. So now we have the area in terms of x, right? Notice that the highest power is 2. So this should be, you know the shape of this image. This should be a parabola. Notice the leading coefficient is negative. That's why I put it in descending power order. Let me make sure you guys can hear me. I know I tend to do that kind of late. I'm sure you guys can hear me, but I usually have my other window open. Let me just join real quick and make sure that's fine. That looks good. Don't connect the audio and join. You guys are pretty state participant. You're pretty good about letting me know if my audio is not working, but I can see my caption, so we're Gucci. Okay, right? So again, we have a parabola. We have a U-shaped curve that opens downward. So the maximum is going to occur at the vertex. We could use the vertex formula, right, to jump straight to the x-coordinate of the vertex. The x-coordinate of a vertex, let me change the color. The x-coordinate of our vertex, which is our h, that's going to be our negative b over 2a. That's our vertex formula. So in this case, it's going to be a negative 135 over 2, and our a is a negative 3/4. Okay. Let's see. This 2 turns this 4 into a 2. We flip and multiply, and double negative becomes positive. So then it looks like it's going to be 2 over 3 times 135. Okay. Let's see, 4 or 5 is a 9. We could do that. Let's see. Was it 4 and 15? So 45 times 2 is 90 meters, right? So the x-coordinate of our vertex is 90 meters. Let me see, what did the question ask? Find the dimensions and the maximum area. So now that we have that our area is maximized, so this is basically the x-coordinate of the vertex of our area formula. So then we can basically use this 90 to find all the missing parts, right? Let's go ahead and find our y. Okay. So then 135 minus 3/4 times 90. Let me see. Hey, Google, what's 135 minus 3/4 times 90?
135 minus 3 divided by 4 times 90 is 67.5.
67.5. Okay. So it looks like it's 90 meters by 67.5 meters. Okay, that makes sense, right? It looks like the x is longer than the y based on the way that we have it drawn. And the maximum area. Hey, Google, what's that answer times 90?
67.5 times 90 is 6,075.
6,075 square meters. So we got a max area of this with those dimensions. Let's see if this works. All right. So if this were like a proctored environment, the best we can do is just kind of ask yourself if it makes sense in the context of the question. But since we're in Pearson, we're just going to go ahead and submit it and cross our fingers. 67.5. The dimensions, 90. Come on. 90. Dimensions of the larger dimension of each field is 90 meters. The smaller dimension, we got 67.5 meters. And then we got 6075. Oh, wait a minute. Yeah, 60, 75. Come on. 60, 75. Right. So that was a fun little adventure. Hopefully that was okay. Let me see. Guess you guys are okay. You're still here. So okay, we're gonna keep going. Generate. Oh, come on. It gave me the previous one. That's fine. Let me see what it's looking like. Solve the given quadratic inequality by sketching the graph of the corresponding quadratic function. Okay. How did you get 67.5? Okay. So come on. Once we got the 90, right? If you're able to follow it up until the 90 meters, that was our x. So then we wanted to go back. We just plugged it into the earlier equation that we had for y, right here. We just plugged in x right there, and that's where the 7.5 came from. Come on. Come on. It's frozen. Well, anyway, where you see that red C on my end, my other one is frozen for whatever reason. Okay, let's try this again, right here. Man, it is. There we go. It's like, man, it's like a 30-second delay. Oh, that sucks. Okay, anyway, but that's where the 67.5. So then once we had our X out to get the max area. Uh-oh. Hang on. Hang on, I'm coming. I don't know. It's like I'm the only person here. Like I don't even understand why they be behaving. It's just temperamental. And this is why I be like optimize the video. This is why I do my pre-recorded lectures as best I can. Anywho, okay. So hopefully, let me see if there are any other questions. Yeah. You good? Okay. So we're back over here. Solve the given quadratic by sketching the graph. So if we want to sketch the graph of this guy, it's probably a good idea to get it in standard form. So one way we can go about doing this is by completing a square. Or we can use the vertex. We can use the vertex formula. I'm more inclined to using complete square here. So I'm going to get a copy and take some notes real quick. There. A little bit. I think that's the pertinent information. Right here. Try it again. Oh, I remember that technique. Maybe I'll go back to that. I mean, this seems like let me just stick with this right now. Okay, so we're gonna do a demo on completing the square here so that we can get this guy into standard form. Okay. So let me start by getting a copy. We have this x squared minus 4x plus 3. Now it says it's strictly greater than 0. So for right now, we're going to treat it like an equation. If we're going to do completing a square, the first step is the leading coefficient needs to be a 1, and it already is. So we're fortunate there. Can we just factor this? Maybe we can just factor this. Two numbers that multiply to give us 3 and add to give us -4 is -3 and -1. I mean, yeah, that seems like that's okay. Let me see. Give me a moment. Let me just kind of keep going with completing the square just to see, because we could factor this, but I want to do completing the square. Let me just do that real quick. Okay, so then the completeness squared step comes in the following form. So we have this x squared minus 4x. So then we want to say plus b over 2 squared and minus b over 2 squared. So what we're doing is adding 0 in this form so that we can change this into a form that where we can use it, all right? And so the plus 3 essentially just comes down. Again, we're really just treating it like an equal sign. So our b in this case is the -4. So we're doing what? -4 over 2 squared. There's a plus there and a minus -4 over 2 squared. Okay. So then that's what a -2 squared is a +4. So we're really saying plus or minus 4. Okay. I'm just bringing everything down. Okay. So now we have 4 more terms. Now we're going to do factor by grouping. So I'm going to group those first 3 together. If we factor those first 3, it looks like it's going to be x minus 2 squared, like this. X minus 2 quantity squared. All right. And then -4 plus 3 is -1. Hey, what's the time? Okay. We got 10 minutes. Man, we did not make it far, but that's okay. So in this form, now we can quickly see that the coordinates of our vertex are h comma k. It's going to be 2 comma -1. Leading coefficient is a +1. So we have the coordinates of the vertex. So then we can use the axis of symmetry. So I mean, we didn't have to do completeness square. We could have also used the vertex formula, right? And then once we had the vertex, we plot the vertex. We see that the leading coefficient is positive. So then we just kind of choose a few additional points, and we can use the axis of symmetry. So whenever we get a point on one side, we automatically get a point on the other. So let's go ahead and plot this vertex of 2, -1. So click to enlarge. So here, over 2 and down 1. Oh, looks like it's difficult. There we go. We got it. So then let's see, when x is 0. When x is 0, y is 3. So I'm trying to get to 3. That looks right. So all I did was, let me make sure these are edit coordinates. All right. So I think that's supposed to be a 3. Submit. Can I edit this one too? 2, -1 looks good. I'm gonna hit save, right? So again, we just use the vertex, and then I just found an additional point. So an easy point to use or to find is when x is 0 in this case. Okay, so let's check. Okay. So again, now we did a demo on completeness square. Again, you could have used the vertex formula, the -b over 2a, and just start with the vertex, then use your axis of symmetry. Just whenever you get a point on one side, you automatically get a point on another. The solution set, use the graphing tool to graph the function. Oh, okay. So then it says it's basically asking, when is this parabola positive or greater than 0? So it's above the x-axis, basically on either side of the x-intercepts. All right. So we need those x-intercepts. So this is where we can, since we already have it like in the standard form from completeness square. We're going to use that. If we didn't have that, then we could also use the quadratic form. Negative boy couldn't decide to go to the radical house because he was square, so he missed out on 4 awesome chicks, and it was all over by 2 a.m. In other words, -b plus or minus the square root of b squared minus 4ac all over 2a, right? So you can use that, but since we already have it in standard form, I'm going to use this guy here on that second to last line, and I'm going to use that to solve. I'm going to set it equal to 0 and solve, right? So we have this x minus 2 squared minus 1 will equal to 0. Add 1 to both sides, so then we'll get x minus 2 squared equals 1. Take the square root. I'm going to continue working over here. So then you get x minus 2 equals plus or minus 1, right? So whenever we do even root, we need plus or minus. And then add 2. So x equals 2 plus or minus 1. Okay? So it looks like it's 1 and 3. Or x intercepts, which we would have gotten. I think originally we had it in factored form. So I think we had it originally from there as well. So 1 and 3. So then basically when we're left of 1 or right of 3, that's when this parabola is above the x-axis. So we need to capture that in interval notation based on the x-axis, right? So the far left here, let me, for instructional purposes, we might have time for one more. So from here, let me just kind of showcase it here, right? So the x-intercepts, so say this is our x-axis. Here's our 1, here's our 3. It's positive over here, it's negative here, and it's positive here, right? Based on the graph. So then we want to know when is it positive. We said left of 1 and right of 3. If we want strictly greater than 0, so these are going to be parentheses. So then we need to capture that blue part in interval notation. So I think once you if you can understand the concept of how to do this graph in black and blue that we have, that's the hardest part for this interval notation. So then from there, now we just translate it into interval notation from the graph. So the far left is negative infinity up to 1, and then we're going from 3 to infinity. In this context, infinity always gets a parentheses. 1 and 3, because again, we want to be strictly larger than 0, they're going to get parentheses, and we combine this with the union. So this is going to be our interval notation. Okay, so this means that any point that's left of negative 1 or right of 3, that's where the parabola is going to be above the x-axis. I have time for one more, depending on how quick it goes. Let me see. Come on. Let's see if you behave, because I know how you like to throw tantrums. Okay, parentheses, negative infinity up to 1. I'm going to say cup. And then from 3 to infinity. Okay. So that's the portion of the x-axis where the graph is above the x-axis, right? That's the portion of the domain where the graph is above the x-axis. Okay. Let's try to get one more in at least. Generate question 60. And so, I have at least 2 other groups today. We're going to be doing something similar, obviously different questions. That's why I use the random number generator. So, feel free to tune into those. Those are today at 2 o'clock and 3 o'clock. So I'll be doing this. And I know we didn't get through that much. That's why I'm kind of mentioning it to you all. So you can always use it as a reference. Use the factor theorem in synthetic division to decide whether the second polynomial is a factor of the first. Okay. Let me see. 4, 3, 2, 1, 0. We don't need any placeholders. Okay, let's take some notes here. It shouldn't be too terribly long. So again, if x plus 4 is a factor, that means when we do synthetic division with the potential 0, we should get a remainder of 0, right? If we don't get a remainder of 0, then it's not a factor. Okay, so let me get a copy of this guy. I was like, well, maybe I should just keep going and make my videos in advance and then use those videos during class. I could do that. I'll be live. So that looks good. We're just going to expand you. So yeah, okay. All right. So if x plus 4 is our factor, then that means that the potential 0 is going to be negative 4. So that means negative 4 goes in the chair. I think every power is accounted for, so we don't need any placeholders. So we just take our coefficients. Since to the power of 4, we should have 5 numbers here. It's 2, 6, negative 7, 5, and 17. 1, 2, 3, 4, 5, right? So I think we're good to go there. Again, the first number just comes down. Okay, on the diagonal, we multiply, so that's going to be a negative 8. We add negative 2, positive 8, positive 1, negative 4, positive 1, negative 4. And the remainder is not 0, right? That's the whole point. It's 13, right? Which is not 0. So is it a factor? Let me make sure I did that right. 2, 6, negative 7, 5, and 17, negative 4, negative 8, negative 2. 4 times 2 is a positive 8. That's a positive 1, negative 4, positive 1, negative 4. Yeah. It's not 0, so it's not a factor. It should not. So is it a factor? The answer should be no. If you were to guess, you would have a 50-50 chance, but chance favors the prepared mind. When we study and prepare and do our homework, we drastically boost the odds of success in our favor. Okay, final check. Okay. All right, gentlemen. So I think that's all we have time for today. We're essentially at the end of class. Yeah, when it comes to this whole academic thing, you know, you just do the best that you can. And if things aren't going the way that you want, you have to know that it's going to be okay. Like, this is what I mean, like, don't take it too serious. Like, where there's a will, there's a way. Whatever, if you really want to do something, there's always some other way to get it done. Even if you fail everything, there's some way. Like, if you really want to do it, there's some way to get it done. And and like, don't feel like you have to do this. You know what I mean? You always have a choice. You always have a choice. And so, like, with our brothers that we lost before, I don't know if anybody ever told them that. Like, you have a choice. Like, you don't have to, you don't have to, you don't have to do anything that you don't want to do. And like, as far as I'm concerned, this is all a game, and that's all I do. I mean, that's why I was late today. I was gaming. It's a game, and it's just like the same intensity and focus and life lessons that we learned during gaming. A lot of that transfers over into reality, and like you can still have the same level of focus and passion, and there are a lot of things that you experience in the gaming realm that you can translate into reality. Um, and I just try to encourage you all to just be true to yourself. One of my same former student that told me, you talking to somebody, they're not saying what you want to hear, you're just talking to the wrong person. She would also say oftentimes, to thine own self be true. Right. So, it's like, don't be too so hard on yourself. Trust, this world is going to be hard enough on you by itself. So be gentle with yourself. Give yourself grace. If you've done your best, release it. I've had to release stuff. I always thought that, like, I should be a doctor. My sister just did it effortlessly. I'm like, how is she doing this? And so, I had to tell myself, I was like, maybe that's not for me. Maybe I think that's what I want, but maybe I don't really want it. You know what I mean? I'm just might be telling myself some narrative that could have been implanted in my mind by my parents and society, where in reality, that might not be the best thing for me. You know what I mean? So it's like, just be open, do your best, forget the rest, don't stress, and be blessed. Okay, gentlemen? You got this. I know you can do it, because you wouldn't be in my presence if you couldn't do it. And if it's still not working, then maybe we just got to step back and reassess the path that we're on, right? But there's always a way. You're here for a reason. You definitely have a light. You have a unique something to offer. It may or may not be on the path that you're on. Maybe you were on this path to meet me. I don't know. Maybe it's to meet one of your classmates. Who knows? Right? But there's always, where there's a will, there's a way, all that kind of stuff. Okay, guys, gentlemen. So let me see. For Wednesday we're probably going to do an attendance quiz, right? I'm going to be here. My intent is to be present. I'll make a quiz anywhere from 5 to 10 questions. You can only access it during class, and you need to pass it. You need to pass that quiz to get attendance credit on that day on Wednesday. So I'll be here for questions. Some quiz anywhere from 5 to 10 questions, and then you complete the quiz and you can be on your way. And then next week, we kind of did the whole rundown. Okay. If there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, enjoy the rest of your day, gentlemen. And we'll meet back on Wednesday, same time, same place, for the next installment. All right, guys. Good luck with everything. Take care and peace. I'll go ahead and make a copy of this available. Need my outro music. It's okay. Let me see. Let me share. That's my old technique, but that's okay. We adjust it. We keep going. Let's go to box. So I'll go ahead and do your attendance as well. Come on, let's go. Fall traditional college algebra 1 notes updated daily. Show 56 looks correct. Choose this folder and upload. All right, gentlemen. Let me see. The chat looks good. Q&A looks good. All right, guys. Let me check one other source, because I know sometimes. All right. See you until next time.